Hello, everyone. So today we will explain the lesson that talk about approximation, how to calculate and round up when we round up, when we round down a given number. Okay. And in the second part of this lesson, we will talk about significant figures. So we will start by the first part, and why do we use when we do use approximation? We have in some cases, some statement, we have to approximate some result of a calculation to make the answer meaningful. Okay, so and sometimes we don't use decimal numbers. We use only integers. So we should approximate our result to make it more meaningful. So first, in the first step, we should learn more about the value of digit. Okay, so we have a number, a real number. A real number in general, it contains the decimal point, as we see here in this figure, in this graph. So we have any real number contains decimal point. On the right of decimal point, we have decimal places, and on the left we have the whole part. Okay, the whole part of this real number. So normally in the right hand side of the decimal point, on the right of the decimal point, if we move from right to left like this, so the first column is called digit unit column. The second one is called the tens column, and the third hundreds column, and the fourth thousand column, tens column, and million, and etc. Okay, sorry, tens, hundreds, thousands, million, and so on. On the right of decimal point, we have tenths, hundreds, thousands, and 10,000s, 100,000s, and millions. Okay, so normally tens, we mean by that it is time 10, the number which is in this place. The value of this digit tens located in the 10th column should be multiplied by 10, thousands by 1,000, 10,000 by 100, by 10,000, etc. Okay, and so on. So in the first exercise, they asked us to write. To write the value of the digit 6 in each number. For example, in the first, in the example part A, 465.9, where we have 6, the digit 6, we have it here. The decimal point is here normally. On the right, we have first unit, and we have tens, so 6 tens. Or we can write it 6 by 10. The value of the digit 6 is 6 by 10. 6, we have here 6 right on the right, directly on the right of on the left of the decimal point. So this is the unit column, so we multiply it by 1. The value is 6 by 1. And we have no decimal point. When we have no decimal point, so we have an integer number, so we can add point on the extreme right of this number. So we have decimal point here, and with zeros, if we want, with zeros. So this is the unit column. 9 is located in the 10th column. 100 columns, so 6 is located on the 100 columns, so 600. So 6 by 100 is the value of this digit 6. So etc. So like here we have the point here, decimal point here. So normally we have directory on the right. The first decimal place is called the tenths. Tenths column, 100 columns, and thousandths columns. Thousandths columns. So we multiply by 1 over 1000, or we divide 6 by 1000. Of these expressions are equivalent. We multiply by 1 over 1000, or we multiply by 1000, etc. Okay, so in the rounding process, if they ask us to round a given number, so normally we have to round to whole part places, or we should round to decimal places. What do we mean by rounding to whole part places? Normally, the whole part places is located on the right, on the left of decimal point. So they will ask us to round to the unit, to tenths, to hundreds, to thousands, or etc. Okay, so we will see. For example, we have here an example to round a number to the nearest thousand. Nearest thousand, so it is located normally on which column? First, second, third, fourth column to the right, to the left of the decimal point. Fourth column. First, locate the digit in the thousand column. First, we located the, for example, here we have this number. Okay, we don't have a decimal point, so we add 1 on the extreme right. Okay, so first place, second, third, and fourth place. Fourth place we have in the thousand, the digit in the thousand column is 6. Okay, is 6. So normally when we located the digit in the thousand columns, okay, because we want to round the number to the nearest thousand. Okay, so first we located the digit in the thousandths column. Secondly, we read or we compare the digit which is placed, located right or directly on the right of this digit 4. 4, we compare it to 5. If this digit is bigger or equal to 5, so we add 1 to the thousand digit, to the digit in the thousand column, we add 1, and we replace all the digits, remains digits on the right of this digit, we replace it by zeros. Okay, so what we mean by that? So we have 436,428. Okay, normally he asks us to round this number to the nearest thousand. Normally nearest thousand, so we have the decimal point here. So first column, second column, third column, and fourth column. So 6 is located in the digit and the thousand column. Okay, so we compare the digit which is directly on the right of this one. Okay, so 4, we compare it to what? To 5. 4 is strictly smaller than 5. So which when the number is strictly smaller than 5, so we don't change this number, which is 6. So we have to not change anything, but we should replace all the number which are on the right of the digit in the thousand column, okay, we replace it by 0. So if the number here like 4 or like another number is bigger or equal to 5, we should add the thousand digit, we should add +1, and we replace all the digits on the right, it's right, we replace it by 0. Okay, so the comparison is with 5 only. Okay, so here we have 6 in the thousand digits, we have 4 on the right, which is strictly smaller than 5. So 6 remains 6, and we replace all the digits on the right, we replace it by 0, as we see here. In the second example, we have, for example, in the thousand, in the digit in the thousand column 7. On the right, we have 8. 8, we compare 8 with 5. 8 is bigger than 5, so we add 1. We add 1 to the thousand digits. So we add 1 to 7, we obtain 8, and we replace all the digits on the right of this number. This digit we replace it by zeros. Okay, if we have, for example, we located first the thousand, the digit in the thousand column. On the right, we have 5. 5 is equal to 5. Normally, it is equal to 5. When it is equal to 5, okay, good. So we add 1 to 7, we have 8, and all the digits on the right, we replace it by zeros. Okay, so very easy. We can complete easily the exercise 3 in the same way. Round each number to the nearest thousand. Normally, we can also figure out what it is happening when we round a given number to the nearest thousand. For example, we have 7,390. Okay. If we want to approximate it or round it to the nearest thousand, so normally we locate the digit in the thousand, which is equal to 7. On the right, we have a 3. 3 is smaller than 5, so we don't change anything here. So 7 remains 7 in the as digit in the thousand column, and all the numbers on the right, we replace it by 0. So that rounding number is 7,000. Okay, what is happening normally? We have the number line. Okay, we put the number line. We have the nearest thousand. The nearest thousand up is 8,000, and smaller is 7,000. We equated 7. We search for the position of 7,390 in this number line. Okay, so it is the nearest thousand is 7,000 and not, because the distance is smaller than the distance between 7,390 and 8,000. Okay, but the practical method is the method that we explained before, like it is very similar to this one. Always we locate the digit that we want to round with respect to. Then we read and we compare the digits on the right, with it is directly on the right to 5, and so on. Okay, so the nearest thousand to 4, 46,500. So we have on the digit in the thousand column, we have 6. On the right, we have 5. 5, it is equal to 5, so we can add 6 to 6, 1, and all the digits on the right, we replace it by zeros. We can say this number is rounding up of this number, because we search for the thousands, which is bigger than this one, because we add 1 for 6 when we say rounded down or rounding down. So we doesn't change anything in the digits, and we replace all the digits on the right by zeros. Okay, so So we can complete also the following exercises, like here, nearest to 100, 100, so the nearest hundreds. So we know that on the right of the decimal point we have unit, tens, and hundreds. So the third column we don't have. We put decimal point, first unit, tens, and hundreds. So 6 is located in the digit in the hundreds column. We have 6. On the right we have 9. 9 is strictly bigger than 5. So we can add 1 to the digit in the hundreds column. We can add 1. So we obtain 47. And we put all on the right, we replace it by 0. So we obtain the rounded up is 4,700, and so on. The nearest tens, so we have 2 in the tenth column. On the right we have 5. 5 equal to 5, so good, we can round it up. So plus 1, we add 1, so we obtain 5,130 because we replace 5 by 0, and so on. Like here, to the nearest whole number. When he say to the nearest whole number, so he mean to the nearest integer. So we don't have in any integer we don't have any decimal point. So normally integer to the whole number. So nearest unit. We have in the unit column 8. On the right we have 3. 3 is smaller than 1. We have 8 on the units column. We have to the right 3. 3 is smaller than 5, so we don't change anything. 148.0, or we say it is equivalent to 148. Okay. And we can complete the following exercises you can complete it by yourself and show me what is happening with you. Okay, in the rounding process we have to round. In some cases we have to round to decimal places. Normally decimal places, if we decimal places, we have tenths, hundredths, so to the places which are on the right of the decimal points. Okay, in the same way we do everything. Okay, like what? We can have abbreviation like 1 decimal point, DP decimal point. Okay, in the same way, 1 decimal point, so the first place on the right of the decimal point. We have the decimal point, the first place is 5, so we have 5. To the right to 5, we have 2. 2 is smaller than 5. 2 is smaller than 5, so we don't change anything on the left. So 63.5, and all the digits here we replace it by zeros, or we can write we can do, or we can replace it by zeros, or we can write it as 63.5. Okay, 2 decimal places, and the second decimal places to the right of the decimal point we have 2. On the right we have 0. 0 is smaller than 5, so we have 63.52. Doesn't change anything here. We don't change anything here, and we put zeros on the right, or we can write it like this. Okay. And the third places, decimal places, first, second, third, so 0, 0 on the right, we have 5. We have 5 on the right, so we have 5 on the right. So we can add 1 here. So we have 521. Oh, 5. Okay, 21, and the 5 we we replace it by 0, or we don't have to put anything. Okay, 63.521, or etc. You can also do the remaining exercises by yourself. And the last idea, when a number was rounded to the nearest 10, the answer was 60. We have 60 here. He asked me to find the smallest number could have been, the smallest number that we can round it to 60, to the nearest 10, and gives us 60. The smallest one, how to obtain the smallest one? The smallest one, is like 55. How to obtain it? So normally we can say that nearest 10, we can write it as K, and the answer 60, this is our number that we want to approximate it, or to find the nearest number that we could round it to 60 to the nearest 10. Okay, the smallest number, we can find it? The limit, or the lower the lower limit of the smallest number is like n 60. Okay, 60 minus k, the nearest 10, k over 2, 10 over 2, so minus 5. So we obtain 55 at the smallest one. The bigger one is smaller strictly than n plus k over 2. So n 60 plus k over 2 plus 10 over 2. So it is equal to 65, as we see here. Okay, and we can see clearly that when we want to find the largest number, the smallest number that could be rounded to 80, we simply subtract from this number the k over 2, because to the nearest 10, so k equal to 10, so minus 10 over 2, so it is equal to 75, and the largest one be strictly, we stress on this, strictly smaller than 85. 85, it is 80 plus k over 2, which is equal 10 over 2, which is equivalent to 5. So the smallest is 75, and the largest is strictly smaller than 85. Okay, etc. And you can go on in this exercises and solve it by yourself. Thank you for listening. I'm waiting for any other question. Bye bye.